Okay, these are the notes for section 5.4, sum and difference formulas. These are the different formulas you get, and they're really the same formula. It's take the sine of the sum of two angles, and this is the sine of the difference of two angles. Cosine of the sum, cosine of the difference, sine or tangent of the sum, tangent of the difference. So you'll be given these formulas on the test. You don't have to have them memorized. I just want to see that you can use them. So I'm going to work through a few different examples. The first example, I want to find the sine of 11 pi over 6 plus 3 pi over 4. So this is a sum because I'm adding them. But the first thing I'm going to do is identify what u is and what v is so that I can use this formula. So then I write down the formula. Because for me, I write everything down. It helps me memorize it. You don't have to memorize it, but it's what I like to do. Then I replace the u with 11 pi over 6 and the v with 3 pi over 4. So everywhere there's a u, I put 11 pi over 6. Everywhere there's a v, I put a 3 pi over 4. Then I'm going to replace with the trig function. So the actual value, the sine of 11 pi over 6 is going to be negative 1/2. So I replace with negative 1/2. Cosine of 3 pi over 4 is negative square root of 2 over 2. And notice I'm using parentheses because I'm showing multiplication. Plus square root of 3 over 2 multiplied by the square root of 2 over 2. Then I'm actually multiplying negative 1 multiplied by negative square root of 2 over 2, or negative 1 multiplied by negative square root of 2 is a positive square root of 2. 2 multiplied by 2 is 4. Square root of 3 multiplied by the square root of 2 is the square root of 6. 2 multiplied by 2 is a 4. Since these have the same denominator, I can combine the fraction, and that's where I get this answer. And there's a way to check it in the calculator. You get a decimal approximation, then you could check it that way. The next one I want to do is a cosine. So this is a difference. This is a cosine, the difference of 3 pi over 4 and pi over 3. So my u is 3 pi over 4, my v is 3 pi over 3. I'm doing cosine of u minus v. So here's the formula that I've been given. I replace all the u's with 3 pi over 4, 3 pi over 4, 3 pi over 4, 3 pi over 4. I replace all the v's with pi over 3, pi over 3, pi over 3, pi over 3. I replace cosine of 3 pi over 4 with negative square root of 2 over 2. Cosine of pi over 3 is 1/2. And you can see where memorizing your unit circle really makes a difference. This is going to take you a long time if you have to keep looking back at your answers. You really are expected to have these memorized. Once I replace all these values, I multiply. So negative square root of 2 times 1 is negative square root of 2. 2 times 2 is 4. And then once I multiply and I have a common denominator, I write it as one fraction. There's nothing wrong with this. The book actually does it a little different way. This is just my personal preference. Tangent is the one that bothers people the most. And the reason tangent bothers people, I think, for two reasons. Tangent, it's just not memorizing your x and your y from your unit circle. You have to remember that tangent is y divided by x. And then we're going to have a fraction in this formula as well. So identify u and v. There's the formula, so it's a fraction. Tangent of u plus tangent of v, all over 1 minus tangent u tangent v. I replace all the u's with 2 pi over 3, and I replace all the v's with 5 pi over 4. Then I replace all those values with the numbers from the unit circle. So tangent of 2 pi over 3 is negative square root of 3. Tangent of 5 pi over 4 is a positive 1. Then I have 1 minus tangent of 2 pi over 3 times the tangent of 5 pi over 4. And be very careful. If you get anything wrong here, everything's going to be wrong after that. So make sure that these numbers are correct. Then from here, there's some manipulating going on. In Algebra 2, you were taught to rationalize denominators of binomials. So most of you are comfortable, if I were to change this to, instead of negative square root of 3 first, write it as 1 minus the square root of 3. My denominator is 1 plus the square root of 3. I'm going to rationalize my denominator using a conjugate. And then I'm going to, the purpose for doing this, first of all, is that when I multiply by the conjugate, my denominator is going to be an integer. I'm going to get rid of the radical in the denominator. And it's only changing the appearance. So when I do that, I have to be very careful. 1 multiplied by 1 is 1. 1 multiplied by negative square root of 3 is negative square root of 3. Negative square root of 3 multiplied by 1 is negative square root of 3. When I put both of them together, I get minus 2 square roots of 3. So what I'm saying is I have 1 minus the square root of 3 minus the square root of 3 plus the square root of 9. So that gives me 1 minus 2 square roots of 3 plus 3. That's where I'm getting this. My denominator, I multiply, I get 1 minus the square root of 3 plus the square root of 3 minus the square root of 9. The negative square root of 3 and a positive square root of 3 is 0. Square root of 9 is 3, so 1 minus 3. I clean it up. 1 plus 3 is 4. 4 minus 2 square roots of 3. 1 minus 3 is negative 2. And then I can simplify that fraction. 4 divided by negative 2 is negative 2. Negative 2 square roots of 3 divided by negative 2 is going to give me a positive square root of 3. The other thing that we're going to do with the sum and difference formulas are you're going to be given information about 2 different triangles. So we have a triangle where the angle is U, and we have a different triangle where the angle is V. And I'm given the information that both angles are in the second quadrant. So the first one I'm going to draw is this angle U. I should do it this way. Since it's in the second quadrant, I draw a coordinate plane, I draw a triangle in the second quadrant, and I'm given sine of U, so this is the angle U. Opposite is 2. Hypotenuse is 3. Opposite is 2, hypotenuse is 3. So I get 2 squared plus x squared equals 3 squared. When I solve that, I get x squared is equal to 9 minus 4, so x squared is equal to 5. So x is equal to plus or minus the square root of 5. But since I'm moving left, it's a negative. Then I do the same thing with angle V. So angle V is also in the second quadrant. I drew this in the second quadrant. Since this is cosine, my adjacent is negative 5. My hypotenuse is 8. So I know that negative 5 squared plus y squared equals 8 squared. So y squared is equal to 64 minus 25. So y squared is equal to 29, or 39. And then it's plus or minus the square root of 39. But since I'm moving up, it's a positive. Once you set that up, if you're careful and you set this up correctly, the rest is easy. I want to find cosine of u plus v. So there's my formula. Cosine of u plus v is equal to cosine u cosine v minus sine u sine v. I don't know what u and v are, and that's okay. I don't need to. I look back at my diagram. Cosine of u. Here's u. Cosine is negative square root of 5 over 3. That's what I replaced. Cosine of v. So for v, I've got to look at this one. Cosine is negative 5 over 8. So I replace it there. Notice I'm using parentheses to show multiplication. Minus sign, sine of u, so 2/3. Sine of v, square root of 39 over 8. I multiply. Negative square root of 5 times negative 5 is a positive 5 square root of 5. Minus 2 square root of 39. Denominator in both cases is 24. Since they have the same denominator, I can write it as one fraction. And there's a process to check these. I could calculate what u is equal to. I could calculate what v is equal to. And I could get a decimal answer and check it that way. I will do more with this on the live lesson.